Everyone. Today we are going to learn something really exciting. So that is nothing but quantum key distribution, also called QKD. We also understand one of the most famous methods, that is nothing but BB84 protocol. So don't worry of the sounds. I will explain in very simple way from the basics of what it is, how it works, and why it is considered the future of secure communication. So first, what is quantum key distribution or QKD? It is a method that helps two people. That helps two people. We call them as Alice and Bob to share a secret key with each other. To share a secret key with each other. So these key will later be used to lock and unlock secret messages. So the special part is that quantum key distribution doesn't use normal electrical signals like computers do. It uses quantum particles like photons, which are very tiny particles of light. And because of the rules of quantum physics, if anyone, say the hacker, if anyone hacker tries to look at these photons, their state changes instantly. Okay. So, and because so Alice and Bob can easily detect that someone is trying to spy or hack. That's why we say quantum key distribution does not rely on mathematics for security. It's protected by laws of physics. Laws of physics. So amazing, right? So even nature itself protects that secret key. Okay. Moving on to the most famous QKD method, that is called BB84 protocol. It was invented in 1984 by two scientists, Charles and Bennett, Charles Bennett and Gilles Brassard. That's why it is called BB84 protocol. The idea is very simple. We use direction of light. So what are the directions of light in polar in photon qubit? Vertical, horizontal, horizontal, vertical, diagonal, anti-diagonal. So we use the direction of light or polarization to represent the information, that is nothing but zeros and ones. Zeros and ones. Okay. There are two ways or bases to represent bits. So one is called rectilinear. Rectilinear is nothing but it is a combination of vertical plus horizontal. If it is vertical, we call it as ket 0. If it is vertical, we call it as 1. If it is horizontal, we call it as 0. Whereas we'll be having diagonal and anti-diagonal. If it is diagonal with 45 degree, we call it as 0. If it is anti-diagonal with 135 degree, it can be like this, or it can be like this. We call it as 1. So each photon will carry one of those directions. So every light particle becomes one small part of the secret key. That is the main idea of BB84 protocol. Now, moving on to the key preparation. So the first step happens with Alice. So she wants to create a secret key. So she starts by generating two random lists, a list of random bits, that is nothing but zeros and ones, and a list of random bases either plus or into. So she encodes each bit using the chosen base. For example, 1 in plus basis becomes vertical, that is nothing but it is rectilinear, right? So which becomes vertical. So 0 in the into basis, it becomes 45 degrees. 1 into basis, which becomes diagonal. So 0 in plus basis becomes horizontal. I think from this slide you need to refer rectilinear and diagonal. Okay, this you need to remember. So from that I wrote these. Okay, so she now has the sequence of photons each carrying one piece of secret information. So now it is ready to send to Bob. Now what happens here? So the next Alice sends those photons through quantum channel. So it may be plus or it may be into. So these will be sent through quantum channel. It could be a fiber cable or even in the air we can send these messages. So on the other hand, Bob receives them, but here is the twist. Bob doesn't know which base Alice used for each photon. So she randomly chooses the bases. So you need to remember this. She randomly chooses plus into symbols, okay? To measure every photon. So if Bob's base matches Alice's base, so he gets the correct bit. If Bob's base doesn't match, he gets a random bit. Okay. Because of this, around half of the bits are expected to mismatch. So because if I send from Alice send plus and Bob chooses from random bit, it will be collapsed. No information will be stored. If it is plus and plus, then only Bob will match it and Bob will store it. Okay. Now, so this is how bases will be compared. So after Bob finishes measuring all photons, Alice and Bob talk to each other over public channel. This you need to remember. I already referred in quantum communication. You can also refer that video. It is like a phone call or internet. Okay, they will be exposing their information to know whether the bases are correct or not. They are using public channel, that is nothing but classical channel. So but they only talk with about which basis they use, not the actual values. So in place we are having 0 and 1, in into also we are having 0 and 1. They will only ask about these bases. They won't showcase these bases in classical channel. Okay, let's see the table. So in the first line both used plus plus. If you observe here, both used plus. Yes, keep that information as, and the result will be 1. If there Alice has chosen into and Bob has chosen plus, plus means rectilinear, into means diagonal, you need to remember. No, so the result will be not stored. Okay, discard them. If in the third qubit the bases are matched, you keep the information. In the fourth one the bases doesn't match, remove it. Okay, so the bits they keep from what's called a shifted key. Okay, only if basis matches, they will, that basis we call it as shifted key. Okay, so now both Alice and Bob have identical secret bits that no one else knows. Yes. So now if someone is hacking, let us say, so what if the hacker tries to read the photons while they are traveling? So here is the magic of quantum mechanics. If hacker tries to look at or measure the photons, they will instantly change their states. So when Bob measures them, some results will be wrong. There will be errors. So Alice and Bob check these by comparing a small random sample of bits publicly. That is nothing but classical channel. Okay. So if there are only few differences, all good. But if there are too many errors, more than 11%, this is percentage, more than 11%, that means hacker is spying. Okay, then they simply discard them and try again. That is why quantum communication is naturally protected. No one can secretly copy or read the data. So that is why we use quantum communication and we say quantum communication is 100% hack proof. So now final key distribution. So once Alice and Bob confirm there was no spine, they move to final step. That is nothing but generating the secret key. Okay. So they fix all small mismatches using something called error correction. What is that? They will be using error correction. if something some error, small errors comes, they will be using error correction. Then they apply privacy amplification. Okay, to make sure Eve knows nothing about the key. Eve is nothing but hacker. Finally, both of them have identical secret key. Like this, I have took an example. This is how they will be matching. This key is now ready to be used for encryption. For example, in sending secret messages, banking data, or defense communication, these keys will be used. Okay. So why it is secure? So Eve cannot copy the information of quantum state due to no cloning theorem. So measurement reveals or measurement will collapse the superposition. Security depends on physics, not max. That is nothing but completely will be depending on nature. Works even against quantum computers. So BB84 forms the foundation of all modern quantum communication networks. That is about BB84 protocol. Thank you guys. If you are having any doubts, let me know in the comment section.